Hello everyone, I am Ayush Agarwal from ABES Engineering College, and in today's lecture we'll discuss about the concept of extended relational algebra operators. In our previous example, and in our previous session, we have discussed the concept of Cartesian product and joins. In joins, we have also discussed the concept of inner join and outer join and the different type of inner join and outer join, right? Now, in this particular lecture, we'll discuss the two type of operators. First will be division operator, and next we have aggregate functions. So let us start with our discussion for today. This is a division operator. Now, this is an extended relational algebra operator, and this operator is applied to two relation because we are using division operator, so we require at least two relation to be applied for this operator. So basically, if we talk about division operator, so here you can see that RZ divided by S of X. So R is a relation, Z is a set of attributes in R divided by S is a relation and X is the set of attributes in a S, where X must be subset of Z. So this will be the condition that if we want to apply a division operator between two relations, so this particular X should be the subset of Z. Because why will say that? Because let's suppose y equals to z minus x, and hence z equals to x union z. That is, let y be the subset of set of attributes of R that are not present in attributes of S. So if we apply this rz divided by s of x, so basically the resultant relation will have the attributes of z that are not present in X. So this is the concept of division operator, right? Now the result of division is a relation Ty that includes a tuple T if tuples Tr appears in R with Tr of y equals to T and with Tr of x equals to Ts for every tuple Ts in S. We'll discuss with the help of an example. There you will understand clearly. Now, for a tuple T to appear in the result T of the division operator, the values in T must appear in R in combination with every tuple of S. Let us understand with the help of an example. There you will find very easily how to apply this particular operator in DBMS. So here we have two table here. First of all, we have SSN underscore P numbers and we have Smith underscore P numbers. So here you can see that under SSN underscore P numbers, we have two attribute ESSN and P number. And in this particular table, we have only one attribute that will be P number. So first of all, if we want to apply division operator between this and this, so what we need to do, we need to understand that this particular relation which have some attributes must be the subset of this. So you can see that P number, it is also available in this. So we can say that the attribute in Smith underscore P numbers is a subset of the attributes present in SSN underscore P numbers, right? So first of all, when we apply a division operator, so we have seen that this particular P number will be cancelled out with this particular attribute, and the resultant relation will have only this ESSN, right? So after applying division operator, we'll get only one attribute in the resultant operation, right? So this will be all about number of attributes we have in resultant relation. Now, what about the tuples? If we talk about tuples, so you can see that here we have two values, 1 and 2, right? And then now we have to identify that for 1 and 2, what will be the values here in SESSN, right? So if a particular ESSN number will have both the values of P number which are present in this particular relation, then we will include this particular attribute, this particular value into our relation, right? So if we see that for this P number 1 and 2, this particular ESSN number will have both these values. So this particular value will be added into the resultant relation. So you can see that we have only one attribute named as SSN, and this particular value, this 1, 2, 3 up to 9, will have both the values of Smith underscore P numbers, that is 1 comma 1 and 2. So we are including this particular value into our relation. Now, if we talk about this third tuple, so can we say that this is a tuple that include all the values of P number which are included in this? No, because you can see that this contain only value 3, right? Now, next we talk about this number 4, 5, 3, 4, and so on. So if we talk about this, so these two values or this particular value of ESSN number will have both the values of P number. Let's suppose we have 1 and 2. So here we have 1 for this particular value and 2 for this particular value. So we have all the values for this particular tuple. So we will include this value also in our relation. And after that, you can see that neither of any particular tuple will have these particular two values for correspondingly. So in this case, if we divide this particular table with this particular table, so we'll get only one attribute, that will be ESSN, which will be named as here SSN. And if we talk about the number of tuples we have, so we have only two tuples basically for this one, because this particular value will have both the values of Smith underscore P numbers, and 4, 5, 3, 4, 5, 3, 4, 5, 3, because this value also will have both the values of P Smith underscore P numbers. So we'll get the resultant as only two tuples. Let us consider in this case. So here we have a relation R and we have relation S. So first of all, if we want to apply division operator between R and S, so we need to check whether this particular set of attributes are the subset of these attributes or not. So right, so here we have A attribute, here we have A and B attribute. So we can say that this particular relation or the attributes in this relation are the subset of the attributes of this relation. So we can apply division operator between R and S. So basically, first of all, we'll identify what are the columns will be present in the relational resultant relation. So if we see here, A will be cancelled out with this A, and B will be present in the resultant relation named as T. Now we'll talk about the tuples. Here we see that the value which contain both these value will be coming into the resultant relation, right? So in this case, which value of B will cover A1, A2, and A3, all the three values of A, that will be covered under resultant relation. So if we talk about this B1 value, so B1 will have A1, B1 will have A2, and B1 will have A3 also. Right? So here we will add B1 as a tuple in the resultant relation. If we talk about this B2, so B2 will have A1, okay, B2 will have A3, B2 will have A2, sorry, B3 will have A2, right? So if we talk about B2, so B2 will have only two values, A1 and A3, which will not cover all the values of attributes of S relation. So we'll not include B as the tuple of the resultant relation. Now, if we talk about B3, so you can see that B3 will have A2, A3, and A4. Whereas we will have A1, A2, and A3 in the resultant in the attribute of relation R. So this will not satisfy the condition for division operator. Next, we'll see B4. So B4 will have A1, B4 will have A2, and B4 will have A3. So here B4 will cover all the values of an attribute A of a relation S. So we can include this particular value B4 as our tuple in the resultant relation. So how this will how the division operator works. Okay. Now next we have aggregate functions. So basically aggregate functions are the functions which are used to provide the summary reports, right? It is a type of request that cannot be expressed in the basic relational algebra, which is to specify mathematical aggregate functions on collection of values from the database. So because example of such function include retrieving the average or total salary of employees or the total number of employee tuples. So basically, if we talk about this aggregate functions, where here we have total 5 number of aggregate functions available in a relational database management system, that will be count. Next we have sum, next we have average, maximum and minimum, right? So if we talk about the count function, so it is used to count the number of tuples present in the relation. If we talk about a sum, so it will provide actually it will be applied on a particular column, and it will provide you the a single value for a specific column. So if we have, let's suppose, salary as an attribute, and if we want to check what will be the total salary disbursed by the organization, so we'll apply this sum operator or sum function onto the salary. So it will give you the summation of all the salaries disbursed to the employees. If we want to find the average of any particular column, so we can use this average, and maximum and minimum will given the maximum and minimum value respectively among the attribute. So this will be an example of aggregate function. So basically, this G represents the symbol for aggregate function in relational model or relational database. So basically, if we want to retrieve the maximum salary value from the employee relation, how we can use that? We'll use this employee relation, and under this aggregate function, we have used max of salary. So it will provide me the maximum salary value from the employee relation. If we want to find the minimum salary value from the employee relation, so we will use this min function of the aggregate function, and again we will apply on this salary attribute of the employee relation. So this will be the symbol for aggregate function. This will be the aggregate function which we want to apply. This will be the column onto which this particular aggregate function on applied, and this is the relation name onto which this particular salary attribute exists. If you want to retrieve the sum of the salary from the employee relation, then this query can be used or accessed, which say that employee relation we have, this will be the symbol for aggregate function. We have used aggregate function as sum, and on which attribute it on the basis of salary. If we want to compute the count or count the number of employees and their average salary, so we can do that also. We will use this employee as the relation. This is the symbol for aggregate function. First of all, we want to count the number of employees. So count, and we have used SSN, so we can use any number of or any attribute name here, because if we want to access the number of tuples, so in the relational database or in a particular table, every column has the same number of tuples, right? So we can use any number of column here. And secondly, we want to access the average salary of the employee. So here we have used average, and onto which attribute? Onto the salary attribute, and this will be the employee relation, right? So this will be all about aggregate function. These are the references through which the content is being taken for this lecture video. Thank you so much. If you like my video and you think that this will help you, so please like and subscribe. Thank you so much.